Lastly, there are another few points to mention, like rays. Photons shoot out in rays, and they travel in vectors, for example. This is different than a line because it has a starting point and a direction in which it's flowing, although very similar. So this is the basics of what's known as Euclidean geometry, and we get into Platonic solids in Euclidean geometries and axiomatic um, axioms. So there are two types of non-Euclidean geometry. The first is what's known as hyperbolic geometry. Now, Henri Poincaré was one of the first to explore hyperbolic geometries, and he came up with what's known as the Poincare disk model. In this Poincare disk model, we can begin to see elaborate, beautiful formations of hyperbolic geometries, which is basics of things that go in or come out, concave or convex circles, things that are extruded or intruded, something that is like a bowl or extruded like a sphere. This gets into more than just spheres. This gets into multiple points that begin to converge onto themselves again, like the edge of a kale leaf, and how it has too long of a linear line, and those linear segments had to be broken down into more and more lines within itself, and it begins to go what's called hyperbolic or what looks like curly leaf kale. The lines are forming so fast the leaf can't keep up with it, and it has to create hyperbolic geometries within itself to be able to form all of those lines and keep them in one leaf. And this begins to show on a spherical motion what is known as the sphere or elliptical geometry. Now, elliptical geometry, when we form a line, breaks is not considered Euclidean geometry because it goes outside the rules of Euclidean geometry. For example, parallel lines will segment a circle and it will create 2 points in which they will intersect. So there is this point and there's the back point. What's known as could be polar north and polar south. And so this gets into the fact that there are non-Euclidean geometries that have parallel lines that will intersect as well. As you can see, these two parallel lines will intersect. They're not completely perpendicular. And what is the difference between a perpendicular and a parallel line on a spherical geometry? So a true perpendicular line on spherical geometry will look like that. But it really depends on where you're considering. Since a sphere, any point on a sphere can be the beginning, the end. It can be perpendicular, it can be straight, because a sphere has equal points on all sides. So it really is just frame of reference on a sphere. We're just talking about frame of reference. This, for example, could be considered the front or the back, or the top or the bottom of the sphere. So when we create segments in a sphere, we have lines that intersect, parallel and perpendicular, and that gets into what's known as ecliptic geometry. And this is useful for orbits of stars, circular momentums, toroidal, poloidal drift, lots of different fun stuff to get into when it comes into this type of geometry. This is one of my favorite types of geometry.